Okay, let's take a look at question number 4 on page 331. This one gives us 3 different polynomials going on, 3 different rational expressions, and it looks like we're adding 2 fractions to get to another fraction. Now this one first asks us, what is the least common denominator of these 3 fractions that we have? To do that, I'd like to look at each of the different fractions in their parts. All right, so I'm going to look at this first fraction first and look at what its denominator is. It has a denominator of x squared minus 25. I want to break it into its 2 parts that we have. I notice if I factor this, I'm going to have a difference of perfect squares. So I'll have an x and an x, a plus and a minus, because when I FOIL it back out, I want those middle terms to disappear. And then 5 times 5 would get us to that 25. So if I double check, I'd have x squared, good, minus 5x plus 5x, those 2 will cancel each other out, and then I have 5 times negative 5 to get to that negative 25. So here's my first fraction and the denominator broken up into that part. My second fraction, I'm going to switch colors and take a look at this one. It doesn't have anything I can break up. So it just has x plus 5. I'm just going to keep that in parentheses so I keep that in mind that that is its own unique denominator. And then my third fraction that I see here has a 4x plus 20. I want to break it up into its parts. When I look at what they have in common or what I can factor out, it looks like I can remove a 4 and be left with x plus 5. Now to find my least common denominator of these 3 denominators, what I need to do is just look at which parts we have until all parts are accounted for. So when I say that, I'm going to start with my first one here. I see it has an x plus 5 part, so I need that. I don't have it yet, so here's my beginning part of my least common denominator. It also has an x minus 5 part. That's different from x plus 5, so I need that one. All right, so it has these 2 parts that it's giving to our least common denominator. I look at my second fraction. It has this x plus 5 part, but that's already represented right there, so I don't need to add another one. It's already in there. And when I look at my third fraction, I see I have a 4 times an x plus 5. Well, it already has that x plus 5 part. There it is. But I don't have this 4 part, so I need that in my denominator as well, my least common denominator. So when I see my final answer, here is what my least common denominator would be. It has all of the parts of all of our denominators accounted for. And then part B asks me, without solving this equation, what are 2 numbers that are not solutions? When I look at this, this just means that our denominators cannot equal 0. That is one of our restrictions we've been talking about since chapter 2. And when I see where the denominator could possibly equal 0, this means x plus 5 cannot equal 0 and x minus 5 cannot equal 0. This tells me x cannot equal a negative 5 and x cannot equal positive 5. So 2 numbers that are definitely not solutions are where we have these restrictions in our denominator at 5 and negative 5. All right, that's a good look at question number 4 on page 331. We'll continue to see some of these extra practice examples as we move forward.